Today, I'm going to show you how a simple algorithm called Naive Bayes can classify emails as spam or not spam. Imagine you receive a new email and you want to decide whether it's spam. Instead of guessing, we'll use probability to make a decision. We start with 6 emails. 3 of them are labeled as spam and 3 are not spam. Each email contains words like free, win, or meeting. Our goal is simple. Given a new email, can we predict whether it is spam or not? First, we look at how common each class is. Out of 6 emails, 3 are spam, 3 are not spam. So the probability of spam is 0.5, and the probability of not spam is also 0.5. This is our starting belief, before looking at any words. Next, we analyze the words inside each class. For spam emails, words like free, win, and money appear frequently. For non-spam emails, we see words like meeting, project, and schedule. We count how many times each word appears. This helps us understand which words are typical for each class. Now, there's a problem. What if a word never appeared in one class? That would give us a probability of 0, and the whole calculation would break. So we use Laplace smoothing. We simply add 1 to every word count. This ensures that no probability is ever 0, and the model remains stable. We calculate the likelihood of each word. For example, free and win appear often in spam. They never appear in non-spam. After smoothing, we compute their probabilities for both classes. This tells us how strongly each word is associated with spam or not spam. Now we combine everything. We multiply the prior probability, the likelihood of each word. We do this for both classes. This gives us 2 scores, 1 for spam, 1 for not spam. Finally, we compare the 2 scores. Spam score is about 0.0166. Not spam score is about 0.00139. Since the spam score is larger, we predict the email is spam. So what did we learn? Naive Bayes takes prior knowledge, word frequencies, and probability rules, and turns them into a simple but powerful decision. Even with a small dataset, it can make accurate predictions. I'll walk you through a simple example of how Naive Bayes works for spam detection using Python. First, we import the necessary libraries, including pandas for data handling and scikit-learn for machine learning. Next, we create a small dataset of 6 emails. 3 are labeled as spam and 3 as not spam. This is our training data, and it represents what the model learns from. Then, we convert the text into numbers using something called a bag-of-words model. This is done with Count Vectorizer. It builds a vocabulary of all unique words and counts how many times each word appears in each email. This step is important because machine learning models can't work directly with raw text. They need numerical features. After that, we separate the labels, which tell the model whether each email is spam or not. Now we train the model using Multinomial Naive Bayes. Here, we set alpha equals 1, which means we are using Laplace smoothing. This prevents any probability from becoming 0 if a word hasn't appeared before. Once the model is trained, we can inspect what it has learned. First, we print the class priors, which represent how common each class is in the dataset. Then, we look at the word likelihoods, which tell us how strongly each word is associated with each class. Finally, we test the model on a new email, FreeWin. The model converts it into the same numeric format and calculates probabilities for both classes. We use predict to get the final classification and predict_proba to see the probabilities behind that decision. In this case, the model predicts spam with a much higher probability compared to not spam. After I click Run, the results come out.